Welcome to Matirx, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you're in the right place. Let's dive into today's lesson. But first, please don't forget to subscribe for more videos. Today our lesson is going to be based on the determinant of a matrix. Determinant of a matrix. So first, we're going to talk about the determinant of a 2 by 2 matrix and also a 3 by 3 matrix. Now, to find the determinant of a 2 by 2 matrix, it's just given by the product of the leading diagonal minus the product of the off diagonal. So, for example, if I have a 2 by 2 matrix in the form A11, A12, A21, A22, the determinant, which is denoted as that A, which is the same as this, is given by the A11. So we talk about the leading diagonal first. So the product A11, A22 minus A21, A21, then A12. Yes, so that's how it is being done. So let's take an example on that. Given the matrix A 4, 17, negative 15, 9. Find, this means the determinant of what? A. So we have to find the determinant of A. Alright, so we said that when it comes to a 2 by 2 matrix, we have to find the determinant of a 2 by 2 matrix is basically the product of the leading diagonal minus the product of the off diagonal. So the determinant of A will be equal to 4 times 9 minus negative 15 times 17. So this is going to give us what? We have 36. So this is going to be plus 255, and we get what? 291. Yes, so this becomes the determinant of that matrix given. Okay, so what about a 3 by 3 matrix? So let's talk about the 3 by 3 matrix, the determinant. Okay, so when it comes to a 3 by 3 matrix, let's say of the form A11, A12, A13, A21, A22, A23, we have A31, A32, A33. Now, to find the determinant of this matrix, I already said it is denoted as that A, which is the same as this. Okay, it's given by, for this one you consider only a row or a column. So let's consider the first row. Now the first entry is A11. You take that one, you cross the row, cross the column. What is left there? 2 by 2 matrix is there. So when we cross this row, cross this, we have A22, A23, A32, A33. So So what's left there is A22, A23, A32, A33. Yes. And the next one will be what? Minus. So always remember this. Have plus, minus, plus, minus, plus, minus, plus, minus, plus. So we move, the first one is positive and the second one is going to give us what? Negative. So we explain that one when we get to the cofactors and all right. So the next one we have this next entry being 1, 2. When we cancel row and column, we have A21, A23, A31, and A33. Yes. Then the next one plus. So see there. Look at the order. So the next one will be what? A13. Then you cancel row and column. What is left is A21, A22, A31, and A32. Yes, that's how it is done. All right. So when it comes to this, now at this point, when you take this, what is left here is to use the idea of finding the determinant of the 2 by 2 matrix. So this is going to be A22, A33 minus A32, A23 minus A12 multiply. So it's just the product of the leading diagonal minus the product of the off diagonal. So you have A21, A33 minus A31, A23. Then you have plus A13. You have A21, A32 minus A31, A22. Yes. So when it comes to the determinant of a 3 by 3 matrix, this is how it's been done. You pick a row, each entry, then you cancel a row and a column. Then you pick the 2 by 2 matrix left. Then you do it that way. Alright, so let's take an example on that. Example, if matrix A is, if matrix A being 2, -2, 7, 0, 7, 1, 4, 3, 2. Find the determinant of A. Find the determinant of A. Now, this is a 3 by 3 matrix. So we are going to pick the first row and use it to do it. So the first row, the first entry is 2. When we cancel out what is left, the row and the column, we are going to get 7, 1, 3, 2. Yes. Then move on to the next one. So we have, it should be minus, but already the element there is minus. So this is going to be plus 2. Multiply, cancel row and column, get 0, 1, 4, 2. Yes. Then plus the next entry is 7. Multiply, we cancel, get 0, 7, 4, 3. Then this is going to give us what? We have 2 multiply, so product of the leading diagonal minus product of the off diagonal. So you have 14 minus 3, then plus 2. You have 0, so it's 0 times 2 minus 4 times 1. So we're going to get what? 0 minus 4. Then we have plus 7. 0 minus 28. Yes. So the next thing, so this is just calculator work. So we do the one here. So you have 2 multiply 40 minus 3 will give us what? 11. Then plus 2 times -4 plus 7 times -28. This part will give us 22. We have minus 8. Then minus 196. Therefore, the determinant of A will be equal to -182. And that is the that's the answer that we have there for the determinant of matrix A. So when it comes to 3 by 3 matrix, this is how we do it. And also always note the sign. We have plus, minus, plus, minus, plus, minus, plus, minus, plus. So note those ones. We talk about them when we get to the cofactors. Alright. So in our next video, we'll talk about cofactors and minor. Thank you for watching. Welcome to Matirx, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, you are in the right place. Let's dive into today's lesson. But first, don't forget to subscribe for more videos. Alright, so today our lesson is going to be on minor and cofactor of matrix. So minor and cofactor. So let's start with that of the minor of a matrix. So in here, a minor is defined as a value computed from the determinant of a square matrix. We know what a square matrix is. A matrix with dimension n by n. It's a square matrix. Yes, it means that the number of rows and the number of columns are the same. So we are saying that a minor is defined as a value computed or a value calculated from the determinant of a square matrix, which is obtained after crossing out a row and a column corresponding to the element that is under consideration. So what we are saying here is that when we have a matrix, the form A11, A12, A13, A21, A22, A23, A31, A32, A33. What we are saying is that the value that will be computed from from the determinant of a square matrix, this is a square matrix, this is a 3 by 3 matrix. Yes, and it's a square matrix. It's obtained after crossing out a row and column corresponding to the element that is under the consideration. So let's say we want to calculate for the minor of this entry, the first one. The determinant that will be calculated from crossing out this and this. Then the remaining one here, that becomes the minor of this particular entry. So when I take A11, this column will be out, this row will be out. Then what is left here is this one here. So this one will be given by what? A22, A23, A32, and A33. Yes. So the determinant computed from this becomes the minor of this particular entry, and it can be done for any other entry. So if I say this one here, the minor of A33. Now we cancel row and column. What is left here? We have A11, A12, A21, A22. Then calculate the determinant from that. That becomes the minor of this particular entry. Alright. The minor of an element, let's say Aij, just as I explained. So it is denoted as Mij. So when I write it this way, Mij like this, it means that the determinant is the determinant of the submatrix. So that minor that we are going to calculate is basically about the determinant that you calculate after crossing a row and column corresponding to the element under what consideration. Alright, so with this same ones here, when I take A22, what will be its minor? A22 is here, so it is corresponding to this row and this column. So it means that we have A11, A13, A31, and A33. So the determinant calculated from this becomes the minor of this entry. Alright, so let's take an example on that. Find the minor of the element 3 in the matrix. The matrix A, which is equal to 1, 3, 5, 2, 8, 9, 5, 9, 4. Okay, so what will be the minor of the element 3? Which element is that? So this is the element 3. What is it there? So it means that we're going to talk about the minor of it is found in row 1, so row 1 in column 2, so M12. Now, which row is corresponding to this entry? This. And this column 2 is corresponding to it. So we are going to cancel this row, and this column. So when we cancel that one, we are going to get the remaining one being what? 2, 9, 5, 4. Yes. Then we calculate the determinant from here. And this is a 2 by 2 matrix. So the product of the leading diagonal, which is 2 times 4, minus the product of the off diagonal, which is 5 times 9. So we get 8 minus what? 45. And the answer is negative 37. So this becomes the minor of the element 3. Yes. Now let's take another example on the minor aspect. You are given the matrix A being equal to 2, negative 5, 0, 1, 3, 1, 4, 1, 2. This is matrix A. Determine the minor of the element 4. Where is 4 located? 4 is in what? So we have to find the minor of 4. 4 is in row 3, column 1. So we have to find the minor. So this one is row 3, column 1. So remember is determinant. So in here, this is the column corresponding to 4 and a row corresponding to 4. So this is going to go out. This is the same thing. So we have this element remaining. So we have negative 5, 0, 3, 1. Negative 5, 0, 3, 1. Then we calculate this the determinant. So this is 2 by 2, just like we did for the 2 by 2 matrix. So negative 5 times 1 minus the 3 times what? 0. So we get negative 5 minus 0. So we get negative 5 as the minor of what? The element 4. This is quite simple. Let's take another example on that. Example 3. Example 3. In the given matrix A, which is equal to A, B, V, 1, 5, 1, X, negative 3, 2. Find the minor of the element 5. So which row and which column can we find element 5? It is in the second row column, also in the second column. Alright, so we have to find the minor solution. So we have to find the minor of, so this one will be 2, 2, because it's in the row 2, column 2. Yes. So how will you go about that one? Now we have 5 here. Which row is corresponding to this? Is this one. So this is off. This is the column corresponding to this, and this is also off. What are the elements that we have remaining? We have A, V, X, and what? 2. So how do you find the determinant? This is going to be A times 2 minus X times V. So we have 2A minus what? XV. And this becomes what? The minor of the entry or the element 5. Now let's move on to talk about the cofactor or the cofactors. Cofactors. Alright, if we have a matrix A in the form A, I, J, like this. So if this is a square matrix, we can form a determinant of its element. So let's say A11, A12, A13, A21, A22, A23, A31, A32, and A33. So we are saying that if this is a square matrix, and of course what we have here is a square matrix, which is a 3 by 3 matrix. So if we can form what? A determinant of its element. Now each element gives rise to a cofactor. So if I take each entry, it should be equal to, it should give me a cofactor, which is simply the minor of the element in the determinant together with its place sign. Together with it what? Place sign. Now, the rule for the sign of the cofactors is given by, so this represented as this Cij is equal to -1 exponent I plus j times the minor times the minor. Okay, so the appropriate place signs are given in the form plus minus plus minus plus minus, then plus minus plus. Now when we take this ones here, you see that we have -1 here, I and j. So this, the I represents the row and j represents what? The column. So if I have 1 it means that I'll get in the row here, I'll get -1 exponent 1 plus 1. So 1 plus 1, that will give me 2. So -1 exponent 2 will be what? A positive number. So the first number will be positive. Now if I move on to the next one, I have odd, and that one will give -1 exponent 3. It's going to give me what? A negative number. So that's why the next one is negative. If you move on, if I add 1 and 3, I'm getting an even number. This is going to give me positive. This 3, so I'll get negative, even, positive. Then this odd, negative. This is even, positive. This is odd, negative, and this even, positive. So the sign there come from that concept. All right. So we go by this appropriate rule. Okay. So let's take an example on that. So each element that we have will give rise to what? A cofactor. Yes. So let's take an example on that. Example 1. If A equals 1, 2, 5, 12, 8, 9, 5, 29, 4. Find the cofactors. Okay, so we have to find the cofactors, and we said that for the cofactors, each element will give rise to a cofactor. So these are the elements of set matrix A, and we have to find the cofactors. So we'll take the first one, which is the cofactor. So the first entry is C11, this one. So row 1, column 1. Using the rule, we have -1 exponent I plus j. So in this case, we have 1 plus 1. We get to 1 plus 1. Then we multiply by what? The minor, which is, and this is going to give us what? The sign here, this is going, you get 2. So it means that we have -1 exponent 2. So we are going to get a positive number. So our answer here will the minor from here. If you take the first one and cancel out, you are going to get you get 8, 9, 29, 4. Then this will be equal to what? 32 minus 2, 6, 1. Then you get -2, 2, 9. So this is done by just the product of the leading diagonal minus the product of the off diagonal. So just like we did for the minor. So in this case, what we consider here is the sign. To take the minor, then the assign that we are going to assign against those minors, the minor that we have there. Now the next one will be, we are still in row 1, so C1 2 column 2. Now we have 1 2, so meaning that we have negative 1 exponent 1 plus 2 times the minor, so of 1 2, and this is going to give us what? This is going to give us, we have this odd number, so definitely this is going to be a negative number, so we have negative. Now that entry is at what place? 2 here, so we cancel out, then we get 12 9 5 and 4. Then the determinant will be what? 48 minus 45. Then we get our answer to what? Negative 3. The reason why it's negative, we have the negative here, so it goes to what? A negative 3. Now the next one. The next one is, what is the next entry? We have C1 3. C1 3. Okay. So we are still in row 1. So we have negative 1 exponent 1 plus 3 times the minor, so 1 3. So we have this being 12, so we cancel out 12 5 29. So the element at row 1 column 3, and cancel the corresponding rows and columns. Okay, so this is going to give us what? 3 4 8 minus 40, and the answer is 308, and that is the cofactor for that entry. Now the next one, we are moving on to row 2 column 1. So you have negative 1 exponent 2 plus 1. Definitely this is going to be a negative, this is going to give us a negative result. So we have the determinant here, so 2 5 29 4, and this gives us what? So negative. So this was odd, so it will be negative. That's why we have the negative there. So we have 8 minus 1 4 5, and the answer is we have negative here, so it will affect it, so we will get a positive result here. So we have 1 3 7. Now so the same procedure, we have row 2 column 2, negative 1 exponent 2 plus 2, then multiply by the minor, so you have 2 2, and this gives out what? 2 2. We have 1 5 5 4. Okay, so our result will be 4 minus 25. Then we have negative 21. Then the next one will be still in row 2, column 3. So we have negative 1 exponent 2 plus 3 times the minor, which is 2, 3. Then we have that one be in the form 1. So remember, these ones are obtained by cancelling the rows and the columns. And this is going to be negative. We have odd number there, going to be negative. So 29. Then our answer will be negative. So we have negative 29 minus 10. Then our answer will be negative 19. Yes. Okay, so and the next one will be we are now in row 3, column 1. So you have negative 1 exponent 3 plus 1 times the minor. So you have 3, 1. Then this here, this is going to be positive. So we have 2, 5, 8, 9. Then our result will be 18 minus 40. Then the answer is negative 22. That's for row 3, column 1. Then row 3, column 2 will be negative 1 exponent 3 plus 2. The minor 3, 2. Then that will give us, so this odd, we are going to get negative there. So 1, 5, 12, 9. Then we have negative 9 minus 60. Then our answer is positive 51. Then our last one will be on the row 3, column 3. So we have row 3, column 3. So we have negative 1 exponent 3 plus 3 and the minor 3, 3. Then we have this even, so it's going to be positive. So we have 12, 8 here. Okay, then our result will be 8 minus what? 24, which is giving us negative 16. So all these have become the cofactors. The cofactors. So basically, if you go by, you can go by this rule, or you can use the sign. Now, this is plus, minus, plus, minus, plus, minus, then plus, minus, plus. So in this case, when you calculate for the minor of each element, then you assign the sign to it. So let's say maybe the first entry, after calculating for the minor, I got negative 34. Now the first one is positive, and meaning that it is still going to be negative. What if I have just positive 34? It is still going to be positive. Now if I have, maybe I had a result for the second one here. I had a result to be, let's say, negative 95. Now because this place is negative, this is also negative, it will change to a positive. So you go by this, you just calculate the minor, then you assign the various sign to it. Okay, so thank you for watching. Welcome to Matirx, where math is made simple and fun. Whether you're here to learn, revise, or boost your skills, You're in the right place. Let's dive into today's lesson. First, please don't forget to subscribe for more videos. Alright, today we are going to we're going to look at how to use various methods to solve system of equations, either involving two variables or three variables. Now we have a question here which says that we should solve the simultaneous equations. So we have equation 1, equation 2. We are going to make use of the method of the inverse approach to solve this, making use of matrix. So in this here we can obtain a matrix out of this. So solution, we have 2x plus 3y equals 4. Then x minus 2y equals 5. What will be the matrix form of this? Okay, so what we do is we are going to write it. We are going to write only the coefficients of various variables. So we have 2, 3, 1, and negative 2. Now, these ones are multiplying x and y, such that you see this is a 2 by 2 matrix, and this is 2 by 1. Meaning you can multiply this. So if you multiply this, you should get this one back. It should be equal to the other aspect, the other unit here, the other side. So if you multiply this one, it should be equal to what we have here. Yes, that's the whole idea. So with this in a matrix form, 2 by 2 matrix. Now let's say that this is our matrix A, and this is an unknown variable x, and let's say this is b. Now, in a normal sense, you see that when we have this ones here, the a is multiplying the x variable here, and it's equal to b. We are solving for x. So in a normal sense, if you want this, we are going to multiply by the inverse of what? A. So that this one can go to 1. Then you have your x here. So you're going to multiply both sides by the inverse of what? A. So inverse of A times. Now the inverse of A times A itself will give you what? 1. So it means that x will be equal to the inverse of A times what? The B. And this part is the B. So it means that we are going to make use of the inverse here. So what is left here is to find the inverse of A. And what will be the inverse? It is basically equal to 1 divided by the determinant of A times the adjoint. Times the adjoint. Since this is a 2 by 2 matrix, the determinant is given by what? The product of the leading diagonal minus the product of the up diagonal. This is going to be 2 times negative 2 minus 1 times 3. So you have negative 4 minus 3, then you get negative 7. And that one becomes our determinant. Becomes our determinant of A. Okay. Now, we need to find the adjoint. When it comes to the adjoint of a 2 by 2 matrix, so when about a 3 by 3 matrix, you find the cofactors, then you transpose it. That will give you the adjoint of the 3 by 3 matrix. But in this case, we're talking about 2 by 2 matrix. The whole idea here, how will you go by that? You just interchange the elements in the leading diagonal, then you negate the off diagonal. So we have the elements, this one. So we have 2, 3, 1, negative 2. So the adjoint will be equal to 1. You interchange this one, the leading diagonal. So we get negative 2. they negate the off, negate this one here. Then that one will give you its adjoint. Now the inverse is given by 1 divided by the determinant of A times the adjoint. Yes, so 1 divided by -7 times the -2, -3, -1 and 2, and this is going to give us what? 2 on 7, we have 3 on 7, we have 1 on 7, then we have -2 on 7, and that one becomes the inverse. Now remember we said that x will be equal to the inverse times b, and what is the b here? These are the b elements. We have 4 and 5, so it means that our x will be equal to what? The inverse of a times b. So this should be equal to what? So we have our inverse there, so we're going to multiply by what? The b. So you have 2 on 7, 3 on 7, 1 on 7, -2 on 7, multiplying 4 and 5. How will we do this? Okay, so when it comes to multiplication of matrix, we take a row multiplied by a column, and this is just a column matrix. So when I take this row, I have 2 on 7 times 4, so that will give you what? 8 on 7 plus 3 on 7 times 5, then that will give you what? 15 on what? 7. Then I move down to the second row. 1 on 7 times 4, that will give you what? 4 on what? 7 plus, so -2 on 7 times 5, that will give you what? -10 on what? 7. So this is supposed to be 8 on 7 plus 15 on 7. We have 4 on 7 minus 10 on 7. Now the first part will give us 23 on 7, then we have -6 on 7. What does this element correspond to? So the top one here is the x, and the down one here is what? The y. So let's see. We had the equation as this, in this form. So our x, when after writing it was in the form, so our x is what? Therefore our x is equal to 23 on 7, and y is equal to what? -6 on what? 7. So that's it. Okay, now let's look at an example on this same thing when it comes to solving linear equations using the inverse approach. So example 2, solve the set of equations. We have x plus y plus 2z equals -1. Then we have 3x plus y minus 6z equals 7. Then we also have negative x plus 2y plus 2z equals what? 0. Now the whole idea here, we are going to make use of the inverse approach, just like we did for the first one. The only difference here is that we have 3 set of equations. Yes. So in this case, the first thing we need to do, let's write it in a matrix form, the augmented form. So the first part, so what do we get? We get 1, 1, 2, 3, 1, negative 6, negative 1, 2, 2. Yes. Then we have our variables x, y, and what? Z. And it should be equal to what? Negative 1, 7, 0. Yes. Now, if this is our matrix A, and this is X, and this is B, then A times X should be equal to B. To get S, we multiply by the inverse of A. So both sides. So we have inverse of A, and this will be equal to, this part will give you 1. So multiply by X to get our X. We go to the inverse of A times the B here. Alright, so we need to find the inverse of what? A. Where's A? So we have the element of A being 1, 1, 2, 3, 1, negative 6, negative 1, 2, 2. Okay, so that is it. And remember how we said the inverse is given by 1 divided by the determinant times the adjoint. So when it comes to trigonometry matrix, we have a lot to do here, because the adjoint here, we need to find the cofactors, then we transpose that to give us the adjoint. And when I talk about transpose, it's basically interchanging rows and columns. It isn't that difficult. Alright, so let's calculate for the determinant of A. Determinant of A. So we take this part. So we want to calculate for the determinant of A. We have 1, so we'll take this 1 here, cancel row and column. We are going to get 1, 6, negative 6, 2, 2, like this. And the next one should be what? Negative. Then we have 1 there, so it should be 1 out here, cancel row and column. So the next one is this, cancel row and column, we get what? 3, negative 6, negative 1, 2. So have plus, so you have 2, multiply 3, 1, negative 1, 2. Yes. Then we move on to down 1. So here you have 1 multiply 2 minus 12, so you have plus 12. Plus 12. Minus 1 here, we have 6 minus 6. Then plus 2 times, so 6 minus 1. So you have plus 1. Then this part will give us what? It's going to give us 14, and this will go to 0. Then plus 14, and the answer is what? 28. That's for the determinant of the matrix A. Now, the cofactors. So the cofactors, when we take, so basically in our previous video we talked about if you have to find the cofactors, it's given by the rule. Let's say ij equal to -1 I plus j times the minor. So basically it's about, you can find the minor, then you assign sign to each of the element that you get. So with A11 from the matrix that we had, it's going to be plus, then we have 2 plus 12 equal to what? 14, with A2 1 2, then minus 6 minus 6, you get what? 0. Then with A1 3, this one what? Plus, so you got 6 plus 1, then you get what? 7. With A21, we get negative 2 minus 4 here, and we get our 2. Then A22, what? So plus, so we assign the sign to it. That's why we are doing it that way. This, then we have A23, then we get negative 2 plus 1 equals negative 3. Then we have A31, negative 2, so it should be negative here. Then we have 2 plus 1, then the answer is negative 3. Then we have A32, we have plus A32, this negative, it should be negative rather. Okay, all right, so this one was supposed to be positive, but we had, so A31 will give us negative so let's go back to this part here. A23, that one from set, this one we are using the matrix A, so our A23 will give us negative 3. Then let's consider A31. A31 we have plus, so negative 6 minus 2, so we get negative 8 there. Then A32 we get minus, then we get 6 minus 6, now we go to what? Okay, A32. Okay, so let's go and let's check the one here and see. A32, 32 here, cancel this, so we have 6 times negative, so we have 1 times negative 6, we get negative 6, minus, it should be, so this one is going to be another 6, so we have negative 12. Then at that point we are going to get a negative there, it is going to change it to what? And we have 12 here, then we have A33, and this is going to give us what? Plus 1 minus 3, then we got negative 2. Then our cofactors will be 14 we have 14, 2, -8, 0, 4, okay, so this is going to give us the transpose rather. So when we calculated for the A11 and those, so A11, let's write down those ones first before we write this ones here. So we have A11 is 14, A12 is 0, then we have A13 7, A31 -3, sorry, this should be A21, so we have 2 here. Then A22 give us 4, A23 give us -3, A31 give us -8, then A32 give us 12, A33 -2. Now, to get the adjoint, the transpose of the cofactors will give us the adjoint, and this is denoted as this, and this is going to give us what? 14. So I just interchange the rows and columns. 0, 7, 2, 4, -3, -8, 12, -2. So it's okay. So just like that. Now this is our adjoint. So in this case, we said that to find the inverse is given by, so inverse of A is given by 1 divided by the determinant of A times the adjoint, and this is our adjoint. This is our adjoint. So in this case, what will be our inverse? So 1 divided by, our determinant was what? 28. Then we multiply by what? The 14, 2, -8, 0, 4, 12, 7, -3, -2. Yes. So if this is the inverse given. So it means that we said that when we have to find x, we equal to what? The inverse of A times the B. Now what is our B? Let's go back and check. Our B was this one's here, -1, 7, and 0. So we have -1, 7, and 0. So the inverse times -1, 7, and 0. And the inverse is given by what? 128 multiplying 14, 2, -8, 0, 4, 12, 7, -3, -2. Yes. And this one should be equal to what? Our x. Now if you multiply this will multiply everything here. So take the 14 times -1 plus 2 times this plus this times this. Then move on to the next one. Now at the end, we're going to get 0, 1, and -1. And this corresponds to our variables x, y, and what? Z. So it means that our x is equal to what? 0, our y is equal to 1, then our z is equal to -1. So that is that. Thank you for watching.